Welcome back to CHE 384 Numerical Methods. This is the second lecture. So today we're going to talk about data types and how we can use them to sort of do more advanced programming. This is going to be the first of the videos. I've sort of segmented them into about 15-minute chunks just to help you find the information that you are looking for. Okay, so by now, after the first lesson and sort of going through MATLAB on your own, you should feel comfortable in opening and running some MATLAB programs, differences between scripts and functions, feeling comfortable passing variables into MATLAB and then getting variables out of MATLAB, and then using the online program submission platform that we use to submit that first in-class program. By the end of watching this series of videos, you should feel comfortable knowing the different types of data we can use in programs, how we can create and manipulate arrays and matrices, build simple functions, use some simple built-in MATLAB functions, and then use the plotting programs within MATLAB. Okay, so let's go back to our sort of example chemical engineering problem that we've been using so far, specifically looking at the water-gas shift reaction. So remember, this is the reaction where we take water plus CO and go to hydrogen and water. So let me just put that in here. So water plus CO going to H2 plus CO2. Okay, and so we said we could model the behavior of this reaction, so how much the reaction goes forward, using our equilibrium constant shown here by this equation, and that we could look at the yield by solving this bottom equation. And previously we built that MATLAB program that was going to take in a temperature and give us how much yield we would expect, so how much we should expect, products we should expect to get. But it's unlikely that we're interested in knowing the conversion at only one temperature, right? That might be useful if we said, okay, I'm gonna run a process at 500 degrees C. What is the yield that I expect? But it's more likely that we're going to be interested in knowing, okay, as I change the temperature, what sort of yields would I expect? So we sort of need to change our mindset. So instead of saying, I want to take and put just one temperature in, we probably are interested in looking at the yield, so X, over an array of different temperatures. Right? And so one way that we could do that is take the program that we built yesterday and then write this sort of a table, like I've drawn on a piece of paper, and say input 300 degrees, 400 degrees, 500 degrees, and then put into that program one at a time. Maybe at 300 degrees, our yield is 0.99. Maybe 400 degrees, we go down to 0.75, and then by 500 degrees, probably somewhere around 0.4. Okay, so we could build these tables and write all this on a piece of paper. However, that's not very efficient, right? Because then we just have all this information on a piece of paper. I want to be able to store all these pieces of information in the computer, have the computer do that for us as we go. So what we need to do is move out of this mentality where we're only looking at a single piece of information, right? So what we did yesterday is we were using what's called a scalar, or a single block of information. So sort of like we talked about yesterday, we can think of that variable, say temperature, having this box or this place where we're storing this information, right? And so we could say that that box maybe contained 300 to represent 300 degrees C. Right? So that was very simple, but as we saw on the other page, we probably want an array or a vector of different temperatures to look at. So we're going to call this new variable type an array. And so we can still use our variable t, but this time we're going to store multiple pieces of information within t. So I'm demonstrating that by showing that t is equal to these multiple boxes. So we could put, say, 100, 200, 300, 400, and 500 all within this array, right? So all these pieces of information are still stored within t. So we still maintain our variable is still t, but t now contains 5 pieces of information. And so we can treat either the variable t as a whole, so we can do operations on all the pieces of information, but we can also call out individual pieces of information. So let's say we're interested in this first piece, so where 100 is stored. So we can use what's called an index to access that piece of information. All right, so maybe, sorry, let me change color here. So we can look at what's that first piece of information using t and then the index, which we're going to put within a bracket, right? So in this case, 100 is stored at index 1, 200 is stored in index 2, 300 is stored in index 3, and then same thing for 400 is in 4, and then T5 at index 5. Right, so I can refer to all these pieces of information either as a whole using just the variable t, or I can use them as individual pieces of information by using these indices. So let's see what happens. Let's sort of go and check out how this is going to work in MATLAB. Okay, so here we are back in our MATLAB window. Just as sort of a brief reminder, we have sort of the command space. We have where we are in our folders and what files are available here, and then our workspace where we have all of our variables. So as a brief reminder, we can take any variable, say t, and we can stick, say, 300 in there. When we press enter, we see 300 pop up. And then within that variable workspace, we see t in that variable. So we can do a similar thing if we want to put in, say, the array. So here we can put our variable t, and we're going to set it equal to a set of numbers. And so how we tell MATLAB to expect an array or the set of numbers is by using this open bracket. So here we can put in our array values, say 100, 200, 300, 400, 500. And then we say, okay, we're done putting in variables by having that second bracket shown here. And what you will see is when we finish putting in that closed bracket, the other bracket highlighted, just to sort of show this is all the information that we're going to put in. Okay, so I can hit enter, and now we see t pop back up, showing us what's stored inside of it, 100, 200, 300, 400, 500, just like we expected. And we can see in our variable workspace, the value stored in t has that 100, 200, 300, 400, 500. Okay. So we can access different variables, different pieces of information within t. So we can say take t and look at what information is stored in that third element, at that third index. It's 300, just like we would expect, counting 1, 2, 3, just like we sort of expect. Okay. So we can do manipulations, say take temperature and add, say, 273 to it. And you can see down here at the bottom, the answer when I take t plus 273, they've taken that each of those variables and added 273 to each individual one. So I can do basic mathematical operations. So I could say 2 times t, now I have 200, 400, 600, 800, 1,000, just sort of like you expect. So I'm taking that 2 and I'm multiplying it by every element in that array. Okay, so let's go back and talk about a new type of data that's going to go a little bit farther. Okay, so we've talked about arrays, and so we can store lots of information in these arrays. We can make them as long as we want, but sometimes we need to go to a different shape, and to have more data stored not just in one dimension, but I could store data in, say, 2 dimensions, right? So this is called a matrix, and it looks pretty much just like an array, but instead of only having 1 row, it has multiple rows. Okay, so I could store information in all of these different boxes. So we could say maybe 100, 200, 300, 400, 500. So I can store this not only in a row, so each of these are rows, and then these are columns. But I can put it into the next row. So we could say maybe put in 200, 400, 600, 800, 1,000, and do the same thing maybe in that last row. So 300, 600, 900, 1,200, 1,500, right? And you don't need any sort of pattern. You can put any sort of information in here. And so once again, we have our variable t, and then we have a set of indexes. So now we have this issue, right? Because I have both columns and rows, right? So I need to tell MATLAB not only which column I'm in, so which piece I am in going across, but which row I am in, so which way I'm going down. So I need to tell MATLAB 2 pieces of information. So I'm going to once again use my brackets, and I'm going to put in a comma to separate the row index from the column index. And so MATLAB indexes by rows first. So we'll put a little r in there, and then our column. So if, for example, we wanted to look at maybe this piece of data at 800, it's in the second row and 1, 2, 3, 4th column. So right, so that would be indexed by t parentheses 2, 4. Okay, so let's put this into practice. Okay, so let's just clear out MATLAB so we have a clean workspace to put it in here. So now we can start again. So we're gonna say T, so our temperature, and we're gonna tell MATLAB we're gonna input new data. We're gonna have our open bracket to tell it to expect an array. And then we're gonna just put in data just like we did before. So 100, 200, 300, 400, 500. But we now need to say that next piece of information needs to go on a new line. And how we do that in MATLAB is this semicolon. All right, so you have 100, 200, 300, 400, 500. Now we can put in the second row, which was 200, 400, 600, 800, 1,000. And then we can do this again for the third row, which was 300, 600, 900, 1,200, 1,500. And then we close our bracket, hit enter, and we get this array. And just like we had seen previously, we have the 1, 2, 3, 4, 500 running across the top, and then that 1, 2, 3 going down. Okay, so we can call any data we want. So let's say we want to look at, we want to get out 800, or we're interested in whatever's happening in row 2, column 4. I can put in T, open parentheses, 2, comma 4, hit enter, and out comes 800, right? So it's showing us what's in that 4th column, 2nd row. Okay, so we can do all those sort of same things that we did before. So we could say maybe take 2 times T, and it'll display that data set. Okay, good. So now let's go back. Now, hopefully this is giving you a chance. I recommend that you sit there and you play around a little bit with these different indexes and just get used to to working with them. So let's go back and think about how we can use these new variable types. Okay, so now that we've sort of talked about how we can use different data types, or what the different data types are, we can go back to putting all of this information in at the same time, right? So what we want to do is we want to take this equation and implement it in MATLAB. So when we do this, we need to be a little bit careful because we're dealing with these matrices and arrays. Where this problem is going to come in is, excuse me, we're going to see that we're going to have these multiplications of KEQs, right? So this KEQ is going to come up with, is going to involve matrices times matrices, right? And so as we're going to learn in linear algebra, when I take a matrix or an array and I multiply it by another matrix, that has very specific mathematical meaning. But what we want to do is we want to take, what in essence we want to do is we want to take all of the variables that are stored in T, so all of these things, and I want to make a K and then eventually an X that has this one-to-one correlation. So this is called operations by element. And so we're going to implement that in MATLAB using this period operator. Okay, so let's go in. We're going to take the code that we worked on before, and we're going to manipulate it so that it can take in a series of temperatures, and report back on a series of x's. Okay, so now we're back in MATLAB and we're ready to implement our element by element operator. So the best way to think about this is every time we see a mathematical symbol that's going to be element by element, we can add in that period. As long as there's sort of matrices or possibly matrices involved. So let's go through there and think about each of our operations that are going to take place and see if we need that element by element information. So first, we have this k equals 10 to some sort of power. We want to take that power on an element by element basis, so it gets a period, right? Negative 2.4, etc. has no t's involved, so we can just skip that piece. Here I'm taking a single number and multiplying it by a temperature. So once again, I don't need to put in a period. Here I do on this third piece because I want to take 2,180 and divide it by each of these individual pieces. So I can put in that period right there. Okay, when I calculate A, B, and C, I'm merely taking K, subtracting 1 from each value, taking k, multiplying by -2 to each value, and then just taking k. So I'm not doing any matrix-matrix interactions or doing any sort of multiplication or division that would sort of look funky. Okay, so down here, we're once again in this issue where we need to go ahead and do element by element operations. So I'm just taking all the elements in B and doing addition. Anytime I have addition, don't need to worry about element by element because it's just inherently in there. But I do have an exponential, so I need to put in the element by element array. And then I have a matrix or a vector in A times another matrix or vector. So I still need to do that element by element analysis. And then I have a division. On one side I have matrices, on the other side I'm going to have matrices or arrays. So I have to put in that period. Okay, and so I'm going to do the same thing on the second row. A period here, a period here, and a period here. And we should be good to go. So don't forget to save, and then we can put in, we can run the equation. So let's say x equals WSG conversion T, enter. Oops, and it would help if I spelled it correctly. So once again, MATLAB is going to be helpful and try to guess what I said. So you hit enter, and there we go. We have x, so that desired function, at each of these elements, at each of those t elements. But let's see, what would happen if we forgot to put in our matrix by matrix elements? So let's just go in and take one of these periods out and see what will happen. So I can go in, I can run this conversion one more time, the conversion code one more time, hit enter, and you'll see that we get a single number. And this is because MATLAB, instead of doing the work element by element, is actually doing matrix math. And like I said earlier, we'll get to that when we talk about linear algebra. But for right now, let's go back in. We'll keep it in element by element fashion, which is exactly what we're interested in anyways. And we can go back and get the x's that we want. Okay, so this now works for vectors, but we can make it work. We can check that it works for matrices. So let's make a really simple matrix. Say here t equals I don't know, 300, 400, then 500, 600. So we should see this sort of square-based matrix, and we can once again figure out what the different x's, the different conversions are, these different temperatures. And so this almost 1 corresponds to 300, 0.97 corresponds to 400, then 500 and 600. Right. So this is great, but oftentimes we want to build a large number of temperatures at once, right? We might want to look at temperatures every 5 degrees C from 300 degrees all the way to 1,000. Well, you probably don't want to go in and by hand enter that by hand. So MATLAB has a bunch of built-in functions that are going to help you with array creation and manipulation. So to look at that, so the first one is we're going to use this colon operator. So we can say t equals, let's say we're interested in going from 300. Colon is going to say go to, say 310 degrees in increments of 10. So I'm going from 300 in increments of 10 to 300 and say 20 degrees. And when I hit enter, I see 300, 310, 320, right? So this colon is just going to allow us to make these matrices relatively easier. And we can do this and build really large matrices. So let's say we're interested in going up to, I don't know, 400. We can see 10, and just as easily with a stroke of a key, we could go up to 1,000 without having to type in this case, 71 numbers. Okay, so this colon operator is very useful. We can use this to make matrices by putting in these brackets and doing that semicolon. So maybe we're interested in going in decades of 10, but we'll just go up to, say, 400 here, and then we'll start the next sort of century of values, 400 maybe now in increments of 10 again, up to 500, semicolon to go down to the next row, 500, colon, 10, colon, 600. Okay, so we get this nice array of vectors. The one thing that you're probably going to start seeing, if you're not being very careful, is this next warning with MATLAB trying to be helpful. So let's say I put in 410 instead of 400. When I hit enter, I'm going to get this error pop up called vertcat. It's going to say that the dimensions of the arrays being concatenated are not consistent. The reason for this is there's 10 numbers, 300 to 400, in this first row. But in the second row, I'm saying I'm going to start with 410. So there would only be 9 elements in the second row, and then back to 10 elements for the third row. MATLAB doesn't like that. It only wants to have matrices that have the same number of elements in every single row and every single column. Okay, so we can fix this by just going back and putting in that back to 400. Okay, so the other thing that we can do, if we say, instead of knowing we want to go from 300 to 400 in increments of 10, let's say I want to go from 1 to 10, and I want 10 data points, right? That's sort of pretty easy, but you can see how, because you just increment by 1, but it could get much more complex. So in that case, we want to use what's called the linspace command. We go and we put in the number that we're interested in starting with, the number we're interested in ending with, so say 1 and then 10, and let's say, I don't know, I want 25. I want the length of that array to be 25. When I hit enter, we'll now see that we have 25 values in that array, but we didn't have to go in and do the math in our heads to say, oh, I need to increment by 0.375. So it's just a little shortcut. As chemical engineers, we're going to see some instances where we're not interested in looking at sort of linear spacing, so that linspace, but we're interested in log spaces. So I can look at things on a log grid using log space. So maybe t equals log space, and here I'm going to put in the exponent, so 10 to what power that I'm interested in. Maybe I'm interested in going from 10 to the negative 5 all the way up to 10 squared or 100, and I'm interested in having, I don't know, 100 gradations of that spacing. So now when I put this in here, you can see that I'm changing, that these values are changing logarithmically instead of linearly. So that may come in handy. So the last two highly useful pieces of built-in code that are going to be helpful in building matrices and arrays are called zeros and ones. And zeros is going to build an array made of zeros, and ones is going to build an array of ones. So let's just see what they do, and then we can discuss why this might be useful. So if I type in zeros, zero, zeros, and I put in a single number, it will make a matrix filled with zeros that is that many elements by that many elements, so n by n matrix. So here I have 3 columns and 3 rows. I could put in a different set of indexes, so say 1, 3, and I'll end up with 1 row with 3 columns of zeros, right? And I can do this the other way. So if I want 3 rows with 1 column of zeros, I end up getting that vertical column. And I can do any sort of combination, maybe 3 by 5, 3 rows, 5 columns, and I have all these zeros. Okay, so ones is going to work in the identical fashion. Instead of putting zeros in, I can type in ones. I get a set of ones instead of zeros. This is really useful in computer programming or building these matrices because oftentimes we want to pre-allocate arrays, or say, MATLAB, you should expect a matrix that's 100 elements by 100 elements, and then we're going to use some fancier programming later on to fill in all those 100 elements by 100 elements. Okay? And instead of doing that every single time, changing the size of the array, it's better to pre-allocate, and MATLAB will be much happier with you. Okay, so the last 2 functions that are going to be really helpful are going to be length and size. And these 2 functions, these 2 built-in functions, are going to tell you information about the matrix. So let's first say take our t, and let's say we're interested in going from 100 in increments of 25 to 1,000. And I'm just going to put in that semicolon so it's not spitting out the information to the screen, because such a large array is going to just take up a lot of screen space. So we can see in that workspace area, I have an array that's going to go, that's 37 elements long. But in a computer program, you may not know how long that is. So that's where length is going to come in. So if you type in length, t, and you put t into length, it will come back and will tell you that there are 37 elements in that array. So size is going to work the same way, but instead of being for only 1D arrays, it's going to work for multiple dimensional arrays. So here I could put in size t, and it's going to tell me that I have 1 row with 37 columns in it. Right? So it's going to give us essentially the same information as length with that 37, but it's also going to tell us sort of that depth, how many rows are in there. And I can do this if I say make a matrix, I don't know, let's say t equals 1s 5, 27. I can do size t, and I should get 5 and 27. Okay. So we may get into this much later in the class, but ones and size and zeros can be used to make matrices of even larger dimensions. So really quick is the last sort of thing. We can put in t equals zeros, what do we have, 5, 27, 3 maybe, and now we have a 3D matrix. You can see that when I put in size of t, I have 3 dimensions. So you can think of this as having a flat square with information coming out of the plane. And if I put enter, we can see all this information coming out, and you'll see t is displayed as these sets of colons, meaning everything in row 1, everything in row 2, everything in the rows, everything in the columns, and particularly what's happening in that third shelf of that n dimension. Okay, so let's go over some of our helper functions for creating array creation. So zeros, right? This is going to give us an array of zeros. Zeros, and we use that as zeros. Number of rows that we're interested in, number of columns, and then if you only put in a single number, it makes that square array. Okay, so ones worked very similarly. It gives us an array or a matrix of ones. We do that by ones, number of rows, number of columns. And then we talked about linear arrays where we just said, okay, march us from one number to another number. Here we just type that in as t, the start number, colon, my increment, so say 1 to 10, and that would give us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can do that in any increment that we want. And we talked about line space, which is going to give us our linspace, where we put in the start number, the end number, and how many we want. Okay, and then the same thing we could put in for log space. We put in the exponent, so if we wanted to go from 0.1, we'd put in -1. If we wanted 1,000, we'd put in 3. And then, once again, how many we're interested in. So how many. Okay, so these are sort of our basic array creation helper functions. Okay, so one of the other important things that we're going to need to do especially when we get to matrix math is a thing called transpose. So this function essentially lets us flip these arrays. So let's say we have A equals 1, 2, 3. Plop that in there, we get that nice value out. But I want a vertical array rather than a horizontal array. I can use the transpose function, and that's going to give us that vertical array, or I can use an apostrophe, and it'll do the exact same thing. Okay, so here are a set of useful functions that you will become very familiar with. Particularly, I want to highlight size, which I've already demonstrated. So size will tell us A is a given matrix, and N is the index that we're sort of interested in looking in. So if I didn't have an N, it would just return the size of every single dimension of the array. And if I put in this N, it will tell me, it will give me the size of a specific dimension. Okay, so CLC we've sort of already gone over. That's going to clear a command window. Clear is going to remove all our variables from memory. Length is just like size, but is only for vectors. So it only is going to handle a one-dimensional array. And then these functions, ceiling will round up to the nearest integer, so it'll drop any decimal points, and floor is going to round down. Okay, so sorry, one last concept that I want to introduce to you is how we can put complex numbers in there and larger small numbers. So complex numbers, right, are imaginary numbers. We're going to refer to those as I and J. So all we need to do is say maybe t equals 4 times I, or 4 times j, and now that's an imaginary number. Similarly, we can have, if we have really big numbers or really small numbers, MATLAB likes to store those in scientific notation. So we can put those in there as t equals, I don't know, 4 times 10 caret to the 3, and that will give us 4,000, right? Or we can put in very small numbers, times 10 to the negative 3, and that'll give us 0.004. Okay, so go ahead. I recommend you go in there, play with MATLAB, try putting in some of these large numbers, small numbers, complex numbers, and just get a feel. So as we move on, as we look at large numbers, it becomes inconvenient to store lots of data and try to analyze data as these giant strings. We tend to want to do this using different graphs. And luckily, MATLAB is really good at doing plots. So we're going to look at 3 different types of plots today. So we're going to just use the general plot form. We'll do sort of a scatter plot, and then we'll look at 3-dimensional plots in a second. And then we can use different commands to sort of tell MATLAB how we want to visualize that plot. Okay, so now we're back into MATLAB. Let me clear this screen. We've got our water gas shift function, and so let's say we're really interested in having this very fine gradation of plot temperatures that we want that we're interested in. So let's now say T equals so this is in Kelvin, so maybe room temperature would be about 300 in increments of 50, all the way up to 800 degrees, or yeah, maybe up to 800 degrees Kelvin. Okay, so I'm just going to put in a semicolon just so it's not going to spit anything out. I've stored that variable. You can see that over in the workspace, and now I'm ready to get my answer. So I'm going to create my new variable x. I'm going to set x equal to the output from water gas shift conversion input temperature, and hit enter. And you can see that x has popped up over in that variable space, and we can just visualize that here. So we're seeing conversions from almost 100% down to about 67%. Right? And so already it's sort of hard to know what temperature that 900 is. So what we're going to want to do is make a plot. So the first thing we need to do in making a plot is we need to tell MATLAB that a figure is going to come up. So we can write figure, and we should see this figure window show up. And I'm just going to keep that in this corner while I work, and you can see it should pop back up in a second. So the first and most simplest command is just plot. So we're going to plot temperature, so our x variable, against yield, our y variable. We can hit enter. It's going to take a second to think about it, and then it will pop up our plot. So here we have yield against temperature. So let me put this over here, put MATLAB over here so we can sort of see both things at the same time. So as good engineers and scientists, we should always label our plots. So we're going to do that with the title command. So first we're going to say what is the title. So we use title. Then we're going to put in text. So to tell MATLAB that this is text, I use this quote mark. So that quote mark is going to say text. So don't consider these variables, consider this text. So water gas shift conversion. And that quote to say I'm done inputting text. Close the parentheses, hit enter, and you should have seen this water gas shift conversion pop up in the figure. Right? So we not only want a title, but we probably want to input what are the x-axis and the y-axis. So we do that using x label. Spell that right. And so remembering that our x-axis is temperature in Kelvin. And when we hit enter, it pops up right there. And I can then do the same thing with y label. This is conversion. Hit enter, and then conversion pops up right here. Okay, so very simple plot. But very, very useful. And we can do all sorts of things like save the plot, export the plot, using these various tools up at the top. Okay, so let's try different plot types. Let's try a scatter plot. So we can do scatter, t comma x. Hit enter, and now instead of seeing the line, I see a scatter plot. So I see individual points on that plot. So depending on what data you're trying to look at, it may be more useful or less useful to have a scatter plot versus a line plot. What you'll notice is that the labels went away because this is a new plot. We can change that by using the terms hold on. It should keep what's on the figure as we do modifications. So let's go back. We can add in our title. We can add in the temperature label. We can add in the Y label, right? All I'm doing is using those up and down arrows to rapidly pull back previous commands. So now if I go back up to plot, instead of getting rid of the scatter plot, it's now plotted that line plot over my scatter plot because I had hold on. I had that command hold on engaged, right? And so I can undo this by saying hold off. If I were to go back in and do plot again, it will erase everything because I haven't told MATLAB don't change anything as I go through here. Okay, so the very last data type that I want to talk about is variable strings. So just like we were storing numbers in variables, we can store text in variables. And so these text variables are called strings. So just like we did before with using those labels, we can tell MATLAB that we want to store text using this these quote marks. So I could store the variable or the text string miles in a variable called f just by saying f equals open quote miles close quote. I can do the same thing for a different variable s, and then I can concatenate or put together two strings by essentially using that array form that we saw before, right? So I can stick these together. So x equals open bracket, f s close bracket. And now x contains that essentially array of the two strings. So making a bigger string that would say Miles Davis. Okay, so hopefully at this point you feel much more comfortable and know about the different types of data that we'll be dealing with in our class. So scalars, arrays, matrices, and strings. You've seen how we can create and manipulate those arrays and matrices. You've seen simple built-in MATLAB functions, and you know how to do some simple plotting.